All right, welcome back. We're going to talk about functions increasing and decreasing and how we can tell the difference with the derivative. So, the picture definition for an increasing function is one that looks like this. The points are getting bigger. A decreasing function looks like this. As you move to the right, the function is getting smaller. We've always expected and just pretty much assumed that you see here for the increasing functions how all the tangent lines are pointing up, and pointing up means that it has positive slope, so that just means the derivative is bigger than 0. Similarly here the tangent lines are all pointing down, so they have negative slope. Negative slope means that the derivative, that slope, is less than 0. And we just assumed that when the derivative was always bigger than 0, it was increasing, and vice versa for decreasing. With the mean value theorem, we can actually show why that's the case. So let's look at this scenario here. So suppose the derivative was always bigger than 0, and we want to know, is the function going up? Is it increasing? So the question is, if you start at some point A and move to the right x, did the function actually go up the way we think it did? So in other words, is f of x bigger than f of a? Well, we can answer that with the mean value theorem. The mean value theorem here says that f of x minus f of a all over x minus a is f prime at c for some c here in the middle. Well, under this assumption that the derivative is bigger than 0, then this number is bigger than 0. So if we multiply both sides by the x minus a times the 0 here on the right, we'll get f of x minus f of a is bigger than 0, which tells us that f of x is bigger than f of a, which meant that the graph really did go up. Okay? So the statement here is this. So the theorem is that 1, if f prime of x is bigger than 0 on the whole interval, then f is increasing. And 2, if f prime of x is less than 0, then f is decreasing. Okay? So let's do an example with this. Example, consider the function x cubed minus 27x minus 20. And we want to know on what intervals is the function increasing and decreasing. Okay. All right, so we need the derivative. So the solution would look like this. You take the derivative. You get 3x squared minus 27. You can factor out a 3 here. Get an x minus 9. And I'm going to factor that as x plus 3 times x minus 3. Okay, and that's the derivative. Now, I care mostly about where it's positive and where it's negative. And to help sort that out, it's extremely helpful to know when it's 0. Because then anywhere it's not 0, it's either just positive or negative. All right, so people tend to do this as follows. They will draw the places where f prime is 0. So it's 0 here and 0 here, at 3 and at minus 3. And then you look at f prime, and you want to know, is it positive or negative on each of these remaining intervals? So remember, f prime is x plus 3, x minus 3. And the same thing, here. It's the same function everywhere. But when x is over here and it's smaller than negative 3, like negative 4, then this term will be negative, and this term will be negative. So their product altogether, f prime, will be positive on this part of the interval. Okay? Now in the middle, that x plus 3 term, well, that'll be positive because, for instance, 0 is this interval, and 0 plus 3 is positive. And the x minus 3 term, well, if I'm subtracting 3, this will still be negative because I'm not up to 3 yet. So the whole product of both of those terms would be negative. And on this last interval, the x plus 3 is still positive over here for x is, bigger than 3. And when x is bigger than 3, then x minus 3 is positive. So the product of the whole thing is positive. So what we get is that f prime will be positive on this interval, negative on this interval, and positive on this interval. Now the next step is to do a rough sketch of f. Well, positive just means it's going up. 0 derivative means it flattens out temporarily. And then negative derivative means it's going down. And this derivative is 0 here, it flattens out. And then the derivative is positive, so it starts going back up. So that's the rough sketch of f. And then you can just smooth it out so it looks a bit prettier, and you see that f will have this type of shape. Roughly where this is where negative 3 is, and this is where 3 is. So it's increasing, then decreasing, and increasing. And again, we can see this from before. If, you would have a local max here and a local minimum here, but that's not what the problem is about. So the problem is then to say the intervals on which it's increasing. So it will be increasing on the intervals from minus infinity up to negative 3. And once it gets past 3 to plus infinity, and it'll be decreasing on minus 3 to 3. And that's the answer. All right. See ya.